Hello students, in last video we have studied about displacement reaction. So next chemical reaction we are going to study, and that next chemical reaction is the double displacement reaction. Already we have studied what I mean by displacement and some examples also we have studied. Now for double displacement reactions, one activity is given and we'll see that activity first, then we'll see definition and then other examples of the chemical reaction, double displacement reaction. So in case of activity, what activity is given, just we'll see. That activity is there, you have to take one test tube, and in that test tube you have to take solution, that is BaCl2. You have to take barium chloride. What you have to take? Barium chloride. Then in this you are taking barium chloride solution. You have to take another one test tube, and in that test tube you have to take sodium sulfate. You have to take here. So you are pouring that one sodium sulfate. You are pouring in this. So in this you have to take Na2SO4, sodium sulfate. Sodium sulfate. So after pouring, one chemical reaction will take place, and you will get here in this solution, in this mixture, reaction mixture, insoluble mass will be formed. What will be formed? Insoluble mass. That is, you are saying PPT, precipitate will be formed. Insoluble mass will be formed, and that insoluble mass will be barium sulfate, BaSO4, insoluble mass, barium sulfate will be formed, and you are saying that one is the precipitate, and that precipitate will be their white precipitate. So reaction will write here which reaction actually takes place in this activity. Reaction is there. So which reaction is there? First thing is there, you are taking barium chloride, BaCl2. Name is there, barium chloride, and it is in aqueous state. Plus you are taking sodium sulfate, Na2SO4. Na2SO4. Name is there, sodium sulfate. It is also aqueous, and this reaction mixture, it will form, reaction will occur, and it will form BaSO4. What it will form? BaSO4, and it is in solid state. You can say white precipitate, white PPT will be formed. My name is there, barium sulfate. Barium sulfate will be the name of the product, and remaining another product will be there, NaCl, and it will form twice NaCl. So Na2 is there, Cl2 is there, it will give twice NaCl, and name is there, sodium chloride. Name is there, sodium chloride. Okay. So after this, definition will take, and some examples of this chemical reaction. We will see more examples of the chemical reaction. So definition of double displacement. First I will tell definition, and then we will take another examples. The chemical reaction in which you can say ions in the reactants are exchanged. The chemical reaction in which ions in the reactants are exchanged, and it is forming precipitate, and such chemical reaction is called as a double displacement reaction. The chemical reaction in which ions in the reactants are exchanged, and to form the product or to form the precipitate, it is called as a double displacement reaction. So definition will take, definition is there, the chemical reaction the chemical reaction in which ions in the reactants ions in the reactants are exchanged to form precipitate. Ions in the reactant are exchanged to form precipitate is called double displacement reaction. Double displacement reaction. Displacement reaction. So main thing is that in this chemical reaction, precipitate should form. Precipitate should form. So what do you mean by precipitate? Precipitate means insoluble mass. Insoluble mass will be there. It is also called as a precipitate. So you have to remember this one. So such chemical reaction is also called as a precipitation reaction. Double displacement reaction is also called as a precipitation reaction. Some other examples we'll see about. Some other examples of precipitation reaction, and these are, first one is there, you can take example PbNO3 plus Ki. So PbNO3 twice plus Ki, and it is giving PbI2 plus KNO3, and here I2 is there, 2 is there, to the right side you will multiply here by 2. So potassium are there too, so you will multiply here by 2. So chemical reaction will get balanced. Name is there of this reactant is there. So these are aqueous, this one is also aqueous, this one is also aqueous. And what is meant by aqueous? Solution in water. Aqueous means solution in water. So name of this one is there lead nitrate. Potassium iodide. Name is there potassium iodide. Here name is there lead iodide. And the name of this one is there potassium nitrate. Name is there potassium nitrate. So this is also, and here PPT will be there, and that PPT will be there PbI2. It will form precipitate, and that color of the precipitate is there yellow precipitate, and yellow PPT, you can say yellow PPT will be formed. Precipitate will be formed. So PbI2 is the yellow precipitate. Another reactions will take. Then next reaction I will write to this side. I will rub this one and I will write next examples of the precipitation reaction. Or you can say double displacement reaction. So in that next another example is there. You can take that example is AgNO3 plus NaCl, and it is forming AgCl plus NaNO3. So this one will be precipitate. So here you can say name is there silver nitrate plus silver nitrate. Aqueous is there. Name is there this one sodium chloride is there. Aqueous is there, and here silver chloride, and precipitate will be there, and that precipitate is the white precipitate. So white PPT will be formed here. Color of the precipitate will be white, and name of this compound is there sodium nitrate. Sodium nitrate. So this one is also double displacement reaction. One more example I will give. Precipitation reaction example is there, and that example is you can take BaSO4 plus K2CrO4, and it is giving BaCrO4 plus it will give K2SO4, and here this precipitate will be there, and this precipitate is there, yellow PPT precipitate, solid state is there, precipitate is there, insoluble mass, solid is there, solid, and here aqueous. So here BSO4, aqueous is there, here aqueous is there, here solid, and here aqueous. So name is there, barium sulfate. Here name is there, potassium chromate, and here name is there, barium chromate, and name of this one is there, potassium sulfate. So like this way, there are these examples of the double displacement reaction. So already we have studied double displacement means what, and some 4 examples of the double displacement reaction we have studied. Now we are going to study another types of chemical reaction, and that chemical reactions are oxidation reaction, reduction reaction, and redox reaction. So one by one we'll see which are that reactions. I would rub this one, you have to write this in your notebook. So first, after this next type of the chemical reaction we are going to study, and that one is the oxidation reaction. Oxidation reaction. So name is the oxidation reaction. So what is oxidation reaction? We'll see. So some examples I will write first, and with the help of that examples we will understand what is mean the oxidation reaction, then definition we'll take, and then we'll see reduction reaction. So examples, in that first example is there, already we have studied that examples. So magnesium burns in presence of oxygen. Magnesium burns in presence of oxygen, and it is giving MgO, and here twice MgO, twice Mg. So next one, second one is there, C plus O2, it is giving CO2. Third example is there, you can take MgH2, it is giving Mg plus H2. The next example is there, which we will study in next lessons also. CS3 dash CS3 is there, and it is giving CH2 double bond CH2. So names, these names already you are knowing. So we'll write here magnesium hydride. Here magnesium is there, and this one is there, hydrogen gas. Here name is there, ethane, and here ethene is there, ethene plus H2 gas, hydrogen. So if you observe this chemical reaction, in this oxygen is mixed, oxygen is combined with reactant, and the product is formed. So oxygen is added, and here hydrogen is removed. From here one hydrogen, here double bond will be there, ethene molecule will be there, and hydrogen is removed. So in first 2 examples, you will see oxygen is added, and if you see these 2 examples, hydrogen is removed. So from that we can do the definition of that particular oxidation reaction. So definition we can write, definition the chemical reaction in which oxygen is added or hydrogen oxygen is added or hydrogen is removed is called oxidation reaction. Oxidation reaction. So what is oxidation reaction? The chemical reaction in which oxygen is added and or hydrogen is removed, it is called as oxidation reaction. So you understood oxidation reaction. So after this, next reaction we are going to study, and that one is there hydrogen is added. That means we'll see what type of reaction is there, and that reaction is there reduction reaction. So I would rub this one, then I will see. So so next type is the reduction reaction. So if you see some examples, we'll take first one is the vegetable oil plus hydrogen gas in presence of nickel catalyst and 60 degrees Celsius temperature. Then it will get converted into Vanaspati ghee. So this one is the liquid state, this one is the gaseous state, this one is the solid state. So in this hydrogen is added. So again it will see another unsaturated compound you will take. So you will take CH2 double bond CH2 plus hydrogen gas will take, and here nickel catalyst will take. So what will happen here? So it will get converted into CH3-CH3, and name is there here ethene. Here name is there ethane. So if you will see in both reaction, plus H2 is there, plus H2 is there. So hydrogen is added. So definition we can do: the chemical reaction in which hydrogen is added is called as a reduction reaction. So we'll write definition of the reduction reaction. The chemical reaction in which hydrogen is added and oxygen is removed. Hydrogen added or oxygen is removed is called reduction reaction. It is called as a reduction reaction. So this is definition for reduction reaction: the chemical reaction in which hydrogen is added or oxygen is removed, then it is called as a reduction reaction. Oxidation and reduction, these are exactly opposite to each other. So after this, next example we are going to study, and next type of the chemical reaction we are going to study, and that one is their redox reaction. Oxidation and reduction reaction, that one together both reactions occur. So that reaction we are going to study, and that reaction is their redox reaction. Redox means reduction plus oxidation. Next type of the chemical reaction is their redox reaction. So we'll see what is a redox reaction. Some examples we'll take first, and with the help of that examples we'll understand whether that chemical reaction, what type of chemical reaction is there. So first example we'll take CuO plus H2, and it will form Cu plus H2O. So here two types of reactions are there. From Cu minus O is there, oxygen is removed, O is removed. Oxygen removed means a reduction reaction is there, and in this plus O is there. So what you can say, plus O is there. So you can say here oxygen is added. Oxygen is added. Oxygen is added. So you can say. So here oxygen is removed means reduction reaction is there. Reduction. Oxygen is added means oxidation reaction is there. Oxidation reaction is there. So here both reactions are occurring simultaneously. So a reduction reaction also occurs and oxidation reaction also occurs simultaneously. And such chemical reactions are called as a redox reactions. So you can see again one more thing we'll see. Definition only will take first. Definition: the chemical reaction in which both oxidation and reduction reactions occurs simultaneously is called redox reaction. The chemical reaction in which both oxidation and reduction reactions occur simultaneously, it is called as a redox reaction. Also you can say redox is equal to reduction plus oxidation. So this one is the redox reaction. So now here we'll see. Here this reactant is having oxygen, so it is called as oxidant. Hydrogen, or this reactant is having hydrogen, so it is reductant. This one is the oxidant, this one is the reductant. Now oxidants reduction takes place and reductants oxidation takes place. Try to understand. Substances which are having oxygen, these are called as oxidants, and which are having hydrogen, these are called as a reductant. So here oxidants reduction takes place and reductants oxidation takes place. Such chemical reaction is called as a redox reaction. And the definition we can tell the chemical reaction in which oxidation of reductant and reduction of oxidation takes place simultaneously, it is called as a redox reaction. One more definition we'll write here. I will drop this one, and the second definition, or I will write here upper side, second definition. Definition number 2. Definition second we'll write. This definition is there first. So the chemical reaction in which oxidation of reductant and reduction of oxidants takes place simultaneously. The chemical reaction in which oxidation of reductant and reduction of oxidant takes place simultaneously is called redox reaction. Redox reaction is there. So this one is the redox reaction. Some other examples will take about redox reaction. So you will write this one, and I will rub this one, and I will write another examples of the redox reaction. So you have to write these examples in your notebook or make your own notes. So after this, next examples, other examples of that particular redox reaction we are going to study, and that examples are there. Other examples or more examples are there. So first example is there. You can say ZNO plus carbon, it is giving Zn plus CO. ZNO, you can take this one is their solid state, this one is their solid state, and this one is their gaseous state. So what happens here? From ZnO minus O is there, minus O, that means oxygen removed. Oxygen is removed. So oxygen removed means this one is there, reduction reaction. Reduction reaction is there. Oxygen is removed means reduction reaction. And here plus O is there, that means oxygen is added. So this one is there, oxidation reaction. So both reactions occur simultaneously. So this is also redox reaction. Then next example we'll see, that one is there, MnO2 is there. MnO2. So in case of the MnO2, it reacts with HCl and it gives MnCl2 plus, you can take Cl2 plus H2. You can take Cl2 plus H2. So here, how many Cl are there to the RHS? 2 plus 2, 4 are there. So you will multiply here by 4. So 4 H happen to the LHS. So here how many are there? H, 2 are there. You will multiply here by 2. So 2 2s are 4. Then reaction is balanced. We'll see. Mn1 is there, Mn1 is there. O2 is there, 2O is there. 4H is there, 2 2s are 4. 4Cl is there, 2Cl plus 2Cl. So reaction is balanced. This one is there. You can take solid state. This one is there. Aqueous will take, solution we are taking. This one will be aqueous. Then this one will be there, gaseous state. This one is there, liquid state. So like this way, chemical reaction will occur. Name is there. Here we'll see from MnO2. From MnO2 minus O is there. That means oxygen removed. Oxygen removed means reduction reaction is there. Reduction. And here from Cl, or you can do one thing, directly you can take here like this way. So plus O is there, that means oxygen added. So oxygen added means it is oxidation reaction. Oxidation reaction is there. So first and second example happen. Another two more examples we'll take for reduction and oxidation reaction, that is redox reaction. That example for more study we are taking that examples. We'll see that example, which are that example, or one more example, just one example we'll take. So third example I will take. Example is there, H2S plus SO2 and it is giving S plus H2. S plus H2. Now here, how many oxygen are there? Oxygen are there 2. So we'll multiply here by 2. Now how many hydrogen happen here? 2 2s are 4. So we'll multiply here by 2. So 2 2s are 4. Now sulfur, 2 sulfur plus 1. Now 3s. So this one is there solid state. This one is there gaseous state. This one is there gaseous state only, and this one is there liquid state. So hydrogen sulfide reacts with sulfur dioxide and it is giving sulfur plus H2. And here what happens? In this plus O is there. Okay, oxygen is added, and here minus O is there. Now, so plus O means oxidation and minus O means reduction. So these are the examples of the redox reaction. These are the examples of the redox reaction. Now after this, 2 two more points are there, that points we'll study, and in that which 2 points are there, first one is the corrosion and second one is the rancidity. That also will complete, then our lesson will get finished. So I'll draw this one. So what do you mean by corrosion? Some examples we'll take, and then we'll take rancidity, and what are the ways to prevent the rancidity, that one we'll see. So next point is there, and that one is the, what you can say, corrosion. Corrosion. So what is corrosion, we'll see. So some examples we'll discuss first. When you are bringing new vehicle or a new iron article you are bringing, it is having shine. New vehicle or new iron article you are bringing, then it is having shine. But when it comes in contact with rainwater, when it comes in contact with moisture, air, you can say oxygen, then its dullness goes on increasing, and it is forming, or on its surface brownish layer is formed, and that one is the rust. This is one example. Again, if you will take silver articles, they are also getting rusted. That means black color get developed on that particular silver articles. Whatever pungent will be there on other silver articles, they are becoming blackish in color. Again, copper vessels. If you take copper vessels, slowly greenish layer get deposited on that particular copper vessels. So all these examples are there, and that examples are there of rusting, or you can say corrosion. So corrosion definition will take, and some examples will take. So definition in that: destruction of metal or metals when it comes in contact with moisture and oxygen is called corrosion. So life of that metal goes on decreasing. Life of the metal goes on decreasing. Some examples are there. First example is there, rusting of iron. Rusting of iron. So rust means, you can say Fe2O3. So Fe2O3 dot H2. This is formula for rust. This is rust only, and it is brownish in color. Brownish in color. So how that reaction takes place, we'll see. So Fe is there, plus H2O is there, plus O2 is there, and it is forming Fe2O3 dot H2O. Fe2O3 dot H2O. So we'll see. So here Fe2O3 is formed, and dot H2 is there. You can say that one is the formula for the rust. Formula for the rust. So here, how many oxygen are there here? Here oxygens are there, 3 are there, and here 3 plus 1, 4 is there. So what you can do here, you can multiply here by 2. You can multiply here by 2. So it will form Fe2O3, and after this, so one thing you can do here, or keep this example as it is. So here rust is formed. This is the formula for the rust. This is the formula for rust. Okay. So one thing you can do here, if you multiply here by twice, then oxygen will become 2 plus 2 plus 2, 4, 3 plus 1, 4, and here now hydrogen will become, now what will happen, now we'll see. If you multiply here by 2, then hydrogen will become 4, 2 to the 4, and here it will multiply by 4, then chemical reaction will get balanced. Chemical reaction will get balanced. That means 4 Fe, 2 2s are 4. Then twice H2O, twice H2O is there. Then oxygen. So if oxygen you will count 2 plus 2. Now here 3. Okay. 3 2s are 6 or 4 2s are 8. 8 will be there. Like this way you can do. This is the chemical reaction for the rust you can take. So next one is there. Second, this one example first. Second example is the silver articles. Silver articles get blackened. They will get blackened. They are becoming black. So silver Ag plus, it is reacting with H2S and it is forming Ag2S, and plus hydrogen gas will be given out. So because of this only, it is becoming, you can say, name is there, silver sulfide, and because of that silver sulfide, it is becoming black in color. Black color get developed. This one is there, silver. So twice Ag2S here. Then reaction through Ag, Ag2, S1, and H2 is there. So another one example you can take, and that example is there. Third one, copper vessels get or becomes greenish in color. So why they are becoming greenish in color, that one will see. So copper plus H2O plus CO2, and it is forming copper plus H2O plus CO2, it is forming CuCO3 plus CuOH twice. What it is forming? CuCO3 plus CuOH twice. So because of this CuCO3, it is becoming greenish in color. So these are the chemical reactions, and because of this, copper reacts with carbon dioxide and water and moisture, and it is forming greenish layer. And this one is called as a what you can say, corrosion of the metal. Damage of the metal takes place. So there are different effects are there of that corrosion. We are using steel, iron into the bridges, buildings. Again, we are using for vehicles, and because of corrosion, life of that particular building, that bridge or that vehicle goes on decreasing. So corrosion is what you can say, destructive, and it is harmful for human beings, or it is harmful for the properties. It is damage, it is causing damage to the property. So this one is the corrosion. So corrosion also you can avoid. There are many ways, and for that corrosion we are going to study in next lessons what are the ways to prevent the corrosion. So this one is the corrosion, and after this next point is there, and that next point is rancidity. Rancidity we'll see. So rancidity. What is rancidity? We'll see. Rancidity. So rancidity, in that what happens, we see whatever fried food materials are there, and that fried food materials, if you will keep for longer duration, if you are keeping that fried food materials exposed to the air for longer duration, then their taste and odor changes. smell, odor, taste, it will change. And suppose leftover food, fried food, if you will keep as it is, then it is becoming rancid. That means taste of that particular food material changes when it comes in contact with atmospheric air, moisture and oxygen. So oxidation of that particular oil takes place and it is causing rancidity. So what is meant by rancidity? We'll see. Change in the odor and smell of the fried food materials due to oxidation of oil is called rancidity. Taste also, smell, odor also changes. It is called as a rancidity. And see, in case of the rancidity, there are some ways to prevent the rancidity. And first, how to prevent rancidity, we'll see ways to prevent rancidity. And that ways are there. First way is there. Mixing antioxidants into the oil. Mixing antioxidants into the oil and food materials. And second way is there, packaging that food materials into the airtight container. So packaging food materials in airtight containers. And the third one is there, using nitrogen gas to pack, using nitrogen gas into the packaged food or food packets, you can say. So whatever a kurkure and all you are eating, in that air is there, and that air is there nitrogen gas, and because of that nitrogen gas, it is not becoming rancid. So in this way, this video or this lesson is finished. You have to write the notes of this lesson, and in the next video we'll start new lesson. Thank you.